Hello everyone, my name is Vladimir Araujo and this is the presentation of the paper Hierarchical Transformers for Group-Aware Sequential Recommendation, application in MOBA games. Recommendation systems have become relevant in recent years because of two reasons. On the one hand, to increase game sales, and on the other hand, to improve the user experience. In the case of MOBA games, it is necessary to buy items for a character to improve its stats and also to maximize the chances of winning a game. Recent work proposed to suggest a fixed set of items for a given character. However, they don't consider the inherent sequential nature of the game, which could help recommend an appropriate item. In this work, we propose HT4Rec, a model that exploits sequential information to generate richer representations of users, and in this way, improve the item recommendations that are provided. We release our code for further research in this topic. In this context, the characters are the users. So giving a set of users, enemies or allies, and a set of items, the objective is to compute the probability of recommending an item based on the information of allies, enemies, and the items they have used before. Here we have the model architecture, and this is made up of four major parts. The first part is the input representation layer, which prepares a representation for each character participating in a game, including the character we want to recommend the items to. Then we have the contextual encoder, which is a bidirectional transformer. This generates a group-aware contextual embedding of the target character, which includes information of the other users and their items and a specific time of the game. Later, we have the sequential encoder, which is a unidirectional transformer. This layer is responsible for modeling the sequential dependencies of user-item interactions in a sequence. Finally, the recommendation layer, which is responsible to predict the next item the user should acquire. In order to test our model, we use a Dota2 dataset provided by Cairo. And because the dataset doesn't contain a specific structure for sequential recommendation problem, we proposed the data. We filter out the consumable items because they may not be predictable. And finally, we obtain a dataset with 130 characters, 180 items, and about 4,000 games for training and 10,000 for testing. As a baseline, we include sequential and non-sequential models, and we found that non-sequential methods don't achieve competitive performance, while HT4Rec achieves consistently better results compared to the well-known sequential models. We also performed an ablation study to better understand the impact of the main components of HT4Rec. We found that no use of allies and enemies information drops the performance, and also by increasing the layers and heads of attention improve the performance of the model. Because the model has two transformers, they capture patterns of different levels. On the left, we can see the resulting attention rates of the sequential encoder, for a complete game, and it's possible to see that the model does not have access to future information to predict the items, and in general, it is putting more attention to recent previous steps. On the right, we can see the attention weights of the contextual encoder, and we can see what of the other participants of the game is influencing more for the next item recommendation. It is possible also to see that the model puts high attention on the same character, but also to the enemies and allies. In this paper, we focused on the scenario of item recommendation in mobile games, which is an ideal task for this architecture. However, the specialization of our model makes it suitable for other sequential group-aware item recommendation scenarios. So in order to test it, we simulate another sequential group-aware item recommendation scenario. We construct a dataset by grouping users from the movie lens dataset based on their geographic location. As we can see, HT4Rec reports the best performance, surpassing all the baselines. Thank you so much, and it will be super good to see you during the presentation if you have questions about this paper.